The last thing that I want to cover in today's class is just a few more terms, acronyms, and terminology pertaining to engines and gas power cycles. Now, typically the engines that you'll find in a car are liquid-cooled engines, and so the cooling is provided by a liquid jacket which surrounds the engine. There are other types of engines, typically like the ones that we saw for the two-stroke and the four-stroke for the edge trimmer as well as the lawnmower. Those are air-cooled engines. And the way that you can detect an air-cooled engine by looking at it is you'll see cooling fins sticking off of the engine itself. And so in air-cooled engines, fins provide cooling. And so if you've taken a course in heat transfer, you would look at the efficiency of fins. And a very famous car that had this was the old Volkswagen Beetle. That was what we call an air-cooled engine. Early aircraft also had air-cooled engines that you would find in the 1910s, 1920s. And the advantage of air-cooled is you have a weight reduction. You don't need to have the cooling jacket and all of the pumps and the radiators and things associated with liquid-cooled engines. And liquid-cooled engines, we have a water jacket surrounding the engine, and what this does is it provides cooling because the engine gets hot and we need to reject that heat. And within the cooling jacket, what we would be running is a fluid, typically a mixture of ethylene glycol and water. Now, some other things, if you see engines or cars on the road, sometimes you'll see numbers on the side of the engine like 5.0, 4.4, 3.0. Quite often that is referring to the total engine displacement. And they now do that, well, at least in North America in liters. They used to do it in, I think it was cubic inches, actually, a 302. I don't think it was cubic centimeters. I believe it was cubic inches. But anyways, what this refers to would be essentially the displacement of the engine. So it would be the swept volume, so the bore squared, that's the diameter of your cylinder, and then so the area of that times the stroke multiplied by the number of cylinders. Typically that could be anywhere from a 4-cylinder engine to a 6-cylinder engine. You could have an inline 6, a V6, so they're in a V configuration. Inline would just be straight. 8-cylinder engine and 12-cylinder engines and other variabilities of that. But for the engine displacements, you've probably seen numbers like 5.0 liter, 2.2 liter, 4.0 liter. That's what they're referring to when you see those numbers. Other terminology, distributor-less ignition. On old engines, they used to have a distributor, and what that would do, it was doing the timing of triggering when the spark would actually fire. And so you had the distributor, which was connected to some of the mechanical components of the engine for timing and control. And it would spin around and you would have a mechanical contact, which would then send a high voltage to the spark plug, which would cause a spark. And it was timed properly in order to have the combustion at the right point of the cycle. So for that we had an ignition coil, which essentially is a device that could generate a very high voltage for us for each spark plug. Other acronyms that you may see on engines, DOHC, that refers to double overhead cam. And what the cam is, if you've taken a course in doing cam design as part of mechanical engineering programs, the cams are used to open and close the valves. And those are the things that allow the fresh air and fuel mixture to come in and then the exhaust gas go out. But with a double overhead cam, that particular design is one cam is for the inlet valves, or the intake valves, and the other the exhaust valves. And there are a lot of different designs for that. Sometimes there will be a rocker arm at the top of the engine that the cams are connected to, and that rocker is basically like a teeter-totter, and that is what opens and closes the valves. The valves will have a spring connected to them, which keeps them in the closed position normally, but then you would depress to open them. So that's double overhead cam. OHV, that's overhead valve. And here you would have your camshaft in the engine block. And then that is connected to push rods, which go up to your rocker arm, to open and close the valves. So to draw a little schematic of this, down here would be your crankshaft. Your camshaft might be connected to that mechanically with either a timing chain or some other mechanical connection. And then there's a lobe on the camshaft, and then that pushes this push rod up and down. And then here you would have your rocker arm. So I'll just draw it like that. Like I said, it's a teeter-totter. And then it would be connected to your valve, which is over here. And the valve itself would have this spring on it on the top. So normally it would be in the closed position. And as this moves up, this is going to move down. And given that it has a lever advantage, it could then push and open the valve, or it would close the valve. So that's the mechanism by which the overhead valve would work. EFI, you won't see this very often now because most engines will have it, but electronic fuel ignition. This was coming out in the 1980s. If you look at older engines, you will have, and here what we have is a fuel injector sprays fuel into the inlet manifold, which is where the air is coming into the engine. It goes through an air cleaner first to get all the particulate and dust and particles out. But then it'll be flowing into the engine. The fuel injection, or the fuel ignition, the fuel injector will spray fuel in. That then flows into your cylinder, which would then be compressed and combust. But you would do this instead of a beautiful piece of mechanical engineering. Instead of using, you would have your fuel injector, but it's replacing what used to be used, which was the carburetor, which is a beautiful piece of mechanical engineering if you ever get a chance to take one apart and study it. The reason is because you have a combination of fluid mechanics and thermodynamics all in this one device, where essentially you have a venturi and you accelerate the flow down, And so this is the jet of your carburetor. And in here, there are many, many different designs, but you have a low pressure zone by Bernoulli's equation. You're accelerating the air coming in, and that would be the air going out. But you're accelerating, and consequently you're at a low pressure, and that draws the fuel in, and so you get little fuel droplets here. Carburetors weren't very efficient, though, because you wouldn't atomize the fuel that well. You could flood the carburetor, you could do all kinds of things. But with electronic fuel injection, instead you have a device that at very high pressure will spray in a mist, and that's how the fuel then enters into the airstream. Much more efficient in terms of the combustion that you get out of that. Other things they might find, knock sensors. And what this is, it's a device that detects pinging. And what that is, pinging of an engine is pre-ignition, where the combustion process is beginning too early. So while the piston is moving up, you want the combustion to start a little bit before it gets to top dead center, but not too much earlier. Or what will happen is you get expansion while the piston is still moving up, and that will cause all kinds of problems for your engine. It could destroy it with time. And that's sometimes referred to as being knocking. And a mechanic would be able to detect the knocking of your engine. If it's really bad, you'll notice, because it's going to be very, very rough idle of your engine. Multi-valve engine. Here the standard is one exhaust, one inlet per cylinder. And what multi-valve has is two exhaust, two intake per cylinder. And you'll see these, for example, if it's a 4-cylinder engine, it would be 16 valve. And you'll sometimes see this on the back of the car, 16V, that would denote 16 valve. Or sometimes you'll see even 24 valve double overhead cam. These are different acronyms that you'll see on cars or on the engine block itself. And the advantage with having multi-valve engine is you have better volumetric efficiency of the engine. And so what you're able to do is draw in the air. You're essentially reducing pressure drop. And so it can breathe better. So it can draw in your air-fuel mixture more efficiently, and it can exhaust the burnt hydrocarbons and more effectively as well. And a final thing that I want to say, another acronym, is VVTL-I, Variable Valve Timing and Lift. And there is a lot of other technology. A lot of research has been done on internal combustion engines over the years, and some of that research makes its way into practical applications and real-world engines. But this one was one that was developed. And so it's variable valve timing and lift, and then the -I is with intelligence. And what does this do? It varies the amount of lift for your valves and when they overlap. So it's similar to having two different contours on your camshaft. Because if you've studied cam design, you'll know that the shape of the cam itself can have an effect in terms of when your valve would open or close. And so with this, you could essentially have different types of cams by just changing it electronically.